Morning, welcome to
KidMath number 115a.
KidMath number 115a. So I saw this morning when I got up on an email, this guy Dan Meyer put this problem on his blog and said it was a pretty interesting problem for a lot of different reasons. And I read it and I thought, yeah, you know what, he's right. This is a very interesting problem. So I thought we'd work through it this morning. Okay?
Yep.
Given an arbitrary point P on a line segment AB, let AP be the perimeter of the square and BP be the circumference of a circle. Find P so that the area of the square and circle are
Equal.
Yeah, sorry for not writing out equal, but I wanted to save space. Okay, how do you want to approach this problem?
We have our line segment AB.
Okay.
And we have our point P here.
Alright.
So this side somehow folds into a circle.
Okay.
And this side folds into a square.
Alright, awesome. Yeah, that's great.
And we need the circumference and perimeters to be equal.
You sure?
The perimeter of a square and the circumference of a circle.
Yeah.
Or the area of a square and circle.
Yeah, the areas are equal.
So we need to find... This might be a little hard.
Oh yeah, this is a tricky problem. That's why we're gonna spend a lot of time talking about it. But you got the picture exactly right. So that's a great start. What's the next thing you want to do?
Well, if we could find the side length and the radius of the circle, that would be helpful.
Okay, great. Now what do you want to be true about this circle and that square?
We need their areas to be equal.
You need those areas to be equal. Okay.
Well, unless this area somehow has a pi in it.
Yeah, that's pretty weird, but that can certainly happen, right?
Yeah.
So the area of the circle is pi r squared. That's right. What's the area of the square?
The area of square is length times width. This times this.
Right.
But the length and width are the exact same thing.
Okay.
So it's the same as L squared.
L squared. Alright.
So we need pi r squared to equal L squared.
Okay, great. Definitely a good start.
Well, now what could we do?
Yeah, what are you going to do now? What would you even like to do now?
Well, I would like to get rid of this pi.
It's going to be tough.
Yeah, because then you have an L squared over pi.
Yeah, well, but actually, you've probably never seen a problem. Pi's just a number, right?
Yeah.
Like, what if this was... This is a good thing to talk about. What if this equation instead said 25 r squared equals L squared? What would you do now? Instead of pi times r squared equals L squared.
Well, now you could... Well, 25 times something squared equals another something squared. So you could move this something to the other side and get it to equal 0.
Okay. 25r squared minus L squared equals 0.
Problem is we have two variables.
Yeah, that's the problem.
We need to find out what one of them is. And then we'll know what... If we can find out what one of them is, we can plug it in and find out what the area would be.
Ah, okay, great. Yeah, so we'd like to find out what one of these variables is in terms of the other one.
Well, actually, so it's just 25r squared is L squared.
Yeah, is there any way to simplify that?
Well, 25 is a perfect square. So yeah, you could have 5r as L.
5r equals L. Okay.
So we can...
That's what you would have in this situation. What are you going to have in that situation?
We're going to have the square root of pi times r equals L.
Okay. Great. I'm going to put the camera on pause for just a second.